Welcome to an overview of how nanotechnology is changing the face of energy consumption worldwide and how Nansulate is participating. Nanotechnology can achieve what traditional science cannot. Industrial Nanotech Inc. was incorporated in 2004 to capitalize upon the use of nanotechnology to reduce global energy consumption and carbon emissions. The company has utilized this new frontier of science to develop a line of powerful, water-based, environmentally friendly coatings and coating systems under the Nansulate brand name that have the ability to insulate, prevent corrosion, protect against mold growth, provide lead encapsulation, and provide chemical and flame resistance. Let's take a closer look at the science behind Nansulate and why it is a revolutionary product. Nanotechnology became a new frontier of science when it was discovered that new materials and performance characteristics were possible by manipulating matter at the nanoscale level. To get an idea of the scale, a nanometer is 1/1000th of a meter. For comparison, 10 nanometers is 1,000 times smaller than the diameter of a human hair. One of the advancements that nanotechnology has brought is a more efficient method to prevent heat transfer and thus a new type of insulation material. Nansulate coatings contain a nanocomposite that has an extremely low thermal conductivity. This material is suspended in a high-quality, low VOC, water-based acrylic latex system to provide a means to apply the nanocomposite to a wide variety of surfaces in an efficient and durable manner. There are significant benefits to applying insulation in coating forms such as Nansulate. To explain the method of insulation simply, the technology inside the coating has low thermal conduction, which means that it impedes the ability of heat to transfer through it. When coated onto walls and ceilings, it helps reduce heat gain into homes and buildings in the summer and reduces heat loss from them in the winter, thus lowering energy used for heating and cooling. For industrial equipment, pipelines, and more, it does the same, insulates by means of low thermal conduction, reducing the energy used for heating processes like steam used for boilers and food processing equipment. Traditional fiberglass or rock wool insulation acts as a blanket and insulates by reducing the transfer of heat energy through it. Unfortunately, it is very unlikely to maintain the same ability to insulate over time due to its porous nature and susceptibility to infiltration by moisture, mold, and other contaminants. Even slight compression, which is used to push the insulation into place, further reduces the insulating value of these types of materials, and thus energy savings are diminished as the material succumbs to environmental degradation. Nansulate also insulates by reducing the transfer of heat energy through it. However, because the nanotechnology component has such a low thermal conduction rate and is incorporated into a high-quality coating, it does so in a much thinner layer, a layer that is also clear and can be painted onto many different surfaces. It is not susceptible to infiltration by moisture, mold, or other contaminants, and is not affected by compression, meaning it retains its ability to insulate over time and can be used in high humidity and harsh environments. Thus, Nansulate maintains its energy-saving ability over time and offers a long-term return on investment. Another issue that is solved by delivering insulation in a coating form is thermal bridging. Traditional materials allow thermal bridging to occur through the building studs in other areas they cannot reach. By coating these areas with Nansulate, thermal bridging issues are eliminated. In independent laboratory testing, according to the ISO standard test for thermal performance of building assemblies, Nansulate technology in a thickness of only 3 coats, or approximately 180 microns, was shown to block 34.8% of heat transfer. We see this in action in the following field study done on a home. The study compared a 2.5-year baseline of kilowatt-hour use from energy bills prior to using Nansulate to the same summer months after Nansulate was applied to the ceilings and attics of the home to insulate and reduce thermal bridging. The homeowner used an average of 42% less kilowatt hours on its energy bill because Nansulate was allowing less of the heat externally to transfer into the home, and his air conditioner used less energy to maintain the inside temperature. Many other field studies and test data can be found at www.nansulate.com. Of course, insulating and reducing energy consumption are not the only benefits of Nansulate. Because the nanocomposite it uses is also hydrophobic, which means having a strong aversion to water, it provides excellent corrosion prevention and is resistant to growth of mold or mildew. It also protects the underlying surface from moisture penetration. Let's take a look at an example of what a hydrophobic material looks like in action. This slide illustrates the effect of rain on a roof tile coated on the left side with Nansulate Crystal, the company's newest clear energy-saving coating for roofs. See how the moisture from the rain on the right side has soaked into the tile, yet on the left side the rain sits on top of the coating, not able to penetrate into the tile. The underlying surface is protected. Thanks to the science of nanotechnology, a new insulation and asset protection material has emerged. Nansulate provides the unique combination of insulation with mold, moisture, and corrosion resistance in a coating that can be applied easily to surfaces and is also affordable to a large variety of the population. This novel technology is reducing global energy consumption and carbon emissions. It represents not only the next generation of insulation, but is also a world-changing energy-saving technology.